Welcome to our training on Zero Code Analytics. This initiative is led by the AFRO's Agri-Food Working Group, the African Federation of Operations Research. The Agri-Food Working Group promotes research in agri-food supply chains in Africa for improved data-driven decision-making and enhanced food security. The goal is to support academics and professionals of logistics and supply chain fields. I'm Ali, a researcher of operations research. Today's lesson will cover solving qualitative variables using classification method. First, we will discuss the models, the methods, and the model's workflow. Finally, we show results and models' critical parameters. First, logistic regression fits the data into a steep scale of 1 to 0. Its shape can be seen in this graph. This shape of regression curve makes it easy to separate observations into clusters. Same as for quantitative predictive models, random forest and tree models can be used for qualitative variables as well. Here, the results are classes rather than numbers. KNN, or K-nearest neighbor model, calculates the closeness of each observation to a number of chosen classes. For a neat tutorial on how this is done manually on a small instance, see the tutorial link attached. We will do this through the machine learning cycle of splitting data into training and validation testing data. Training data results in a model with particular setup to solve the problem at hand. The model can then be used to validate the data using the test data and resolve if results are not plausible. This is what the model will look like in Orange. You don't have to use all methods, but the functionality in Orange helps make this easier. First, we input the data through a file import. Make sure to select categorical variable types for the prediction variable. We view the data in a table and select the required columns for our experiment. We then use the data sampler to split the data and connect it to our training models. The model resulting is calculated and saved in the test and score. This gets the data and provides model effectiveness. The correlation matrix shows us how close each testing observation was to the correct observation. Each model has some parameters to tune. This is the mix we use to reach our final results. We didn't change anything for both logistic regression and KNN. KNN scored the highest with default setting. We tried to add more trees for the random forest, a subset of trees, however, it still scored less than the tree model. With a simple right-click, we can add or remove any statistic we want in the score widget. We chose to see the train and test times it took for each model, as it can affect decisions of which model to use. We can see the different matrix that indicate the model's quality. CA, classification, accuracy, F1, precision, and recall all measure the properly classified test observation. You can click on the question mark at the bottom. At the bottom left, read more on each. For those, the higher is better. AUC, area under the ROC, indicates the opposite, so the lower is better. The best modeled results was for KNN and G models, and the worst for logistic regression and random forest. We can see in the confusion matrix widget the distribution of false positives. We can see that the KNN model scored highest and where it scored wrong. And so for the tree model, which is the second in our case. Here, the purple highlighted cells indicate true positive, meaning it was properly predicted, where the other red shaded are wrongly predicted. Thank you for choosing to learn with us. Stay tuned for more on zero-code supply chain analytics.